Hi, this is Mrs. Davis. This is APP Calculus. We're working on the Unit 1 review packet for the test, and we are on the very last section working on the free response questions, and we're on free response question number 3. Now, this free response question is a calculator question. So on the AP exam, you'll have 2 non-calculator and 2 calculators. So here's a good example of how to do the calculator one. You'll notice that usually the functions are a lot harder. And you get decimals as your zeros and things like that. So I'll just try to walk you through how to do this. So they give us a function q that's got a polynomial on the top and polynomial down. So we have a rational function, and it says find all zeros of q or state that there are none and label your answers appropriately. Okay, so what you want to do, and I'm not going to put this in my answer because I'm just talking to y'all, is you're going to do Y1 on your Y1 button to put it so you can graph this, and you're going to put Q of X into your graphing into Y1 in your graphing calculator. Okay? And then you're going to graph it, and then you're going to get the zeros. Okay, and so make sure you know how to do that. If not, you're going to have to ask somebody or ask me if there's time before the test. So make sure that you can do your zeros. That's one of the standard things that you have to know how to do on your graphing calculator. And we've done it in class, but like I said, this is review. So, all right, so once you get that in there, we have to just answer this question. So we're going to say that we have zeros at x equals, and then you should have gotten 2 of them, negative 2.303. Remember, we go out to 3 decimals rounded, and the other one was 1.303. So those are your 2 zeros. All right, let's do part B. Determine if the graph of Q has any horizontal asymptotes and slant asymptotes of Q, and write equations for those, or state there are no horizontal or slant. Give a reason for your answer. So if we look, we're hoping it's a horizontal so I don't have to do long division. And sure enough, I have the same degree. For this, each polynomial has degree 3, and so my horizontal asymptote will be the A over B, which is 1 over 2. So we're going to say Q will have a horizontal asymptote of y equals 1/2, and then we have to say y. And these are the easiest ones to do the limits for. You don't have to figure anything out. So because, and we do the end behavior, the limit as x goes to negative infinity of q of x is equal to 1/2, and the limit as x goes to positive infinity of q of x is equal to 1/2. All right, so that answered the question about horizontal, and then it wanted to know slant. And so even though there aren't any, you need to say it. You need to say there are no slant asymptotes on the graph of G. All right, so that was B. C, find the average rate of change for Q 0 to 1.5. All right, so this is where we're going to make sure it's a free response, that we have a left side and a right side, trying to get all the points. So we're going to say, since we're going to write it out, because we're not going to write AROC on a free response. So the average rate of change is equal to Q of 1.5 minus Q of 0. And remember, you have to have this written down. Then you can put it in your calculator. 1.5 minus 0. And yes, you have to put that you did 1.5 minus 0 because it's showing f of b minus f of a over b minus a. All right, and so then if you use your calculator, you should have gotten Q of 1.5 is negative 0.125. And then Q of 0 is 1. And so then that's over 1.5. And so you get negative 1.125 over 1.5. That comes out to be negative 0.750. Negative 0.750. So that would be the average rate of change. And you just use your calculator. You can go to the table. So once you have this in as a graph, right, it's in y equals. And so if you go to the table, I'll put this here. And remember, you want to make sure that you have it in ask mode. Okay? And that is under the table set. And I showed you how to do that. So make sure you do it in ask. Otherwise, you just have to do more work. And then you can put in 1.5 and for x, and it'll give you negative 0.125. And then you can put in 0, and it'll give you negative 1. All right, so that's like a hint on how to do that. But this part must be written out. Okay, so there would be, if we were calculating points, this would be 1 point, and that means you have to have the left and the right, and you have to have this look like that, and the other point would be your answer. So there's not much else to check because you put everything else into the calculator, so it makes sense. That would only be worth 2. Going down to D, find all x for which Q of x is 12. So that's setting Q of x equal to 12. So we have Q of x is equal to 12. Now, how do you do this on your graphing calculator? Well, you're going to put y2 is equal to 12. So now if you hit graph, you'll have a graph of y1, which was Q of x, and then a straight line, a horizontal line, y equals 12, and you're going to, I should have kept going on this explanation. After you do that, you're going to graph it. This should all be review. And then you're going to look at the intersections, because that's where they would be equal. And so they cross twice. So you would have Q of x equals 12 at x equals, and there's 2 of them, negative 0.461 and 3.113. Hopefully those are right. I'm double checking. Negative 0.461 and 3.113. So there is number 3, free response with the calculator.